All right. Well, it is good to see everybody. Did you have a good Easter weekend? Yeah. Good news is we're 5 weeks out from the end of the school year. In fact, 4 weeks from this Friday, we are done, May 23rd. So it's coming up super fast. I know you're all going to be disappointed when the summer hits and you don't have math anymore, but don't worry, the videos will still be posted so that, anytime you're wanting to just get that knowledge or a good old dad joke, videos are going to be right there for you. I appreciate that, Kyle. Appreciate that. Okay, well, the plan today, as I mentioned just a minute ago, I want to go ahead and talk about, a question or two off of the assignment where we're graphing the log parents, growth and decay, all that good stuff. Then we'll go ahead and wrap up the lesson we started last week, log equals log equations, or at least logarithmic equations, I should say. And then that'll be our class today. Now, tomorrow we'll have a quiz over graphing the log parents. We'll go ahead and move on to the next lesson, which is solving exponential equations using logs, and we'll just keep on going. So I will see you on Thursday, even though there is the Algebra 1 STAR test. But pretty much I think we'll just finish out the week with that next lesson, and we'll go from there. Okay, are there any questions about what's going on? Okay, well, let's go ahead and get to it. All right, so here we go. So we wanted to go ahead and graph each function and identify its key characteristics. Did we want to go ahead and start with, say, number one? This one has no transformations. Or do we want to go ahead and just dive right into one that has transformations? You just want to do number one? Let's do number one. Okay. So log base 3 of x. Now, the way we were doing this, I showed you another method late last week. I'm going to go ahead and do it the original method first, where we go ahead and find a table of values using its inverse exponential. Okay, so this right here. So let's see what we're going into right here. We got log base 3 of x. Okay. Is this a growth or a decay? This is a growth. My base 3 is greater than 1. Okay. So it's going to go ahead and curve up to the right like this. However it's going to end up looking, wherever the asymptote's going to be. And in fact, maybe this isn't a bad idea because it's been quite a few days since we've talked about this. Let's do a quick review. Let's just talk about logs in general. Can anybody tell me what is a log? Okay. It's an exponent. It's a power. That's all it is. It's simply a way of rewriting an exponential. So if I were to give you something like, how about log base 2 of 16? Can anybody tell me the value of that log? Okay. Bobby? It is 4. Now, let's say this is one of those expressions where we don't immediately know what it is. Okay. Remember, whatever log expression you write, it has to equal the power that you're going to place on your base in order to get the argument. Remember, the argument is whatever's inside the parentheses. And we saw for the first time last week, the argument can never be negative and it can never be 0. So let's say we don't know what that is right now. Let's say that power is just represented by x. Okay, so let's go ahead and rewrite this as an exponential. So I'm going to take base 2 to that power x and set it equal to the argument 16. Okay. Once you do that, a lot of students are probably going to be able to visually see what's happening here. I mean, we know that, 2 to the 4th power is going to give me 16. But if you're not able to see that immediately, maybe we could go ahead and rewrite it, take one step further. Because we know that if one exponential equals another and they have the same base, then I can say that the first power equals the second power. All right, so what if I were to give you something like this? Let's say log base 3 of 27. Okay, what's that? Okay, very close. It would be 3. Log base 3 of 27 would equal 3. And why is that? Well, because 3 cubed equals 27. Remember, a log is always the power. Okay. Now, if I had something like this, if I had log base 3 of 9, that would equal 2, because 3 squared is going to give me 9. Okay. Well, let's try something a little different. What if I gave you this? Log base 16 of 4. Can anybody tell me what the value of that one is? What is it? It is 1/2. Now maybe on this one, this is one we definitely want to go ahead and say it's equal to x, rewrite it as an exponential. So 16 to the power of x is equal to 4. All right. Now both 16 and 4, they share 4 in common. Okay, so let's go ahead and rewrite this. Remember, I'm only changing the base. So 4 squared is 16, right? So I'm still going to have this x on the outside, and this equals 4. Well, what do I do when I have a power raised to a power? We multiply. So this would give me 4 to the power of 2x is equal to 4. We just talked about this a moment ago. If there's no power, we understand it to be 1. Bases are the same, so if I cut those loose, 2x equals 1. So yeah, x equals 1/2. And that makes sense because we know that anything raised to the 1/2 power, that's the same as taking a what? A square root. Okay. Now, this one's interesting. We could not only have used a common base of 4, could we have also done 2? 2 would have worked as well. Sometimes that'll happen. Not every time. Okay. Is that starting to kind of come back to folks? Okay. And then we spent some time on properties. That is not what I wanted to do. I didn't want to do that again. It is not letting me erase. There it goes. Let's try this one more time. Okay. Let's say I were to give you something like this. How about log base 4 of 5x? And I just want you to go ahead and expand that for me. Okay. So how do I break apart items that are multiplied in an argument? We add them. Remember, each one of these, the 5 and the x, is going to get a log base 4. So this would be log base 4 of 5 plus log base 4 of x. Remember, you can also condense these. These rules are reversible. Okay. What if I gave you something like this? Log of, let's say, x over 3. Okay. Now, I didn't put a base there. What base is that? 10. Remember, if there is no base, it's base 10, the common log. So how do I break apart division? Subtraction. Remember, fraction, subtraction. Now, does it matter which one goes first? Which one? The x. The numerator has to be written first. So this would be log of x minus log of 3. Okay. And here's our power rule. What if I had log base 5 of x to the 4th? There you go. Any term in the argument that has a power, I can pull it to the front where it becomes a coefficient. So this would be 4 times the log base 5 of x. Okay. And then we started looking at graphing and we're on equations, but how are we doing? Okay. Well, all right. I think that was a pretty good little review. Let's head back up here. Okay. So we got log base 3 of x. So I'm going to use the base to help me get started. Okay. So we're only looking at the exponential parent. We're not worried about transformations, even though this one doesn't have any. So I'm going to take 3 to the x power. That allows me to go ahead and start with the same, if I can write today, same x values every time. Okay. So let's see here. Let's start with the bottom and go up. Let's start with the easy ones. What's 3 squared? 9. 3 to the first? 3 to the 0? 1. Now what happens if you raise it to a negative power? You take the reciprocal. So we're going to flip it. So this would be 1 over 3 now to the positive 1. So that's 1/3. And then what about 3 to the negative 2? That would be 1/9. Okay. Now we are starting with the exponential, but I want to graph a log. We flip them. Remember, they're inverses. So all I do is take the x values and the y values, and we switch them. So now I'm going to have -2, -1, 0, 1, 2. And then this right here, the x's are now 1/9, 1/3, 1, 3, and then 9. So this is x. This is log base 3 of x. That's a 3 right there. And there's no additional transformations, so those points are going to make up my sketch. Okay, so let's see what we get. Where does every log asymptote start? It has a vertical one, but where does it start? Always starts at 0, the y-axis. Okay, and there's no shifts of any kind, so it's going to be right here. Okay, so I already know the asymptote is x equals 0. Okay, let's plot these points. Let's see what we got. So 1/9 is a -2. That's really, really close to that asymptote. 1/3, so about a 0.3. That's a -1. 1, 0. Then we have 3, 1. And then we have 9, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. So we're going to have something like this. Okay, so there's my graph. Anybody have any questions? Anybody lost? Okay. Well, how wide is this? What's the domain? X is greater than 0. Okay. And we've talked about it could show up, different ways, like the solution set or interval notation. If you want me to write that, just let me know. Okay. How tall is it? Yeah, the logs are always infinitely tall, so it's always all reals. Okay. Now let's talk about the end behavior. Okay. When you see those words end behavior, we're talking about the left and the right side. Well, for this curve here, okay, the left side is going to be right there. And then the right side is, of course, going to be right here. Well, let's take a look, because it's wanting me to plug in as x approaches blank, the y values f of x approach infinity. Well, what part of this is it the left or the right where the y values are getting larger? It's the right side. So what does x have to approach for that to happen? Infinity. See, the x values have to keep getting larger for the y values to get larger. So that means that as the y values of f of x are approaching negative infinity, that's got to be the left side right here. Well, what's x got to approach to make that happen? It's got to approach 0, that asymptote. Yeah. And then this one was pretty nice to us. We already have the x-intercept from the table. We know it's got to be 1, 0. There we go. So you'll have a couple of questions like this tomorrow on your quiz. Okay. Now, is there one with transformations that you'd like to take a look at? Okay. 4's actually got 2 of them. Horizontal shift of 8 and then vertical of 4. Okay, let's do that one. Okay, so for this one, okay, now remember, we're going to do this in stages, and then I'm going to go back and show you once again that other method that we did late last week, where you don't have to create as many tables, okay, if you don't like doing this. Okay, so first off, is this a growth or a decay? This is another growth. Our base 2 is greater than 1. Okay, so we're going to go ahead and start with the exponential parent. So only the base to the power of x. Remember, we won't even be worried about those shifts until that last t-chart. Okay, so I'm going to start with the same values. -2, -1, 0, 1, 2. Okay, let's go ahead and plug these in. All right, so 2 squared is 4, 2 to the first is 2, 2 to the 0 is 1. What's 2 to the -1? That's 1/2. And what about 2 to the -2? That's 1/4. Everybody okay where I'm getting those values from? Okay. All right. But again, we're not looking for the exponential. I want log base 2 of x. You'll notice this one right here in the middle, it's just going to be the log parent. Again, we're not worried about the transformations just yet. So I'm going to take these values of x and y, and I'm going to switch them. So now we have -2, -1, 0, 1, 2. And then this one becomes 1/4, 1/2. Then we have 1, 2, and 4. Now we want to go ahead and apply those transformations. Okay. The easiest one is always going to be the vertical. So is this being shifted up or down 4? Okay, so for the y values, I want to subtract 4 from each one of those. Okay, what am I doing with the x's? There you go. See, it says +8, but remember, when you shift horizontally, you take the what? You take the opposite. So algebraically, it says plus, we are going to subtract 8. Okay. So let's see, let's take care of the y's first, because that'll be easy. 2 minus 4 is a -2. 1 minus 4 is a -3. 0 minus 4 is a -4. Okay. -1 minus 4 is a -5. And finally, -2 minus 4, that's a -6. Is everybody okay? All right, well, let's go ahead. Now I need 4 minus 8. -4. 2 minus 8. 1 minus 8. Okay, that's a -7. Now I need a 1/2 minus 8. -7.5. And remember, you got the calculator to help you out with this too. Or you can, do the algebra over to the side. Okay. And now I need a 1/4 minus 8. -7.75. Here we go. Remember, for logs, the only transformation capable of moving that vertical asymptote is the horizontal shift. So if it was originally at 0 and we're going to shift it 8 left, well, that's exactly where my asymptote should be. 1, 2, 3, 4, 5, 6, 7, -8 right there. So I'm going to go ahead and set my asymptote, x equals -8. Okay. All right, let's go ahead and plot these points. Let's see here. So we have a -4, -2. Okay, 1, 2, 3, -4, -2. Then we have a -6, -3, -7, -4. Okay, -7.5, -5, and we'll finish up -7.75, -6. So much closer to that asymptote. Okay, so it's going to curve. That is a horrible curve. I can do better. It's going to curve up through there, just like that. Okay. All right. Well, how wide is it? What's the domain? X is greater than -8. There you go. How tall is it? All reals. Remember, exponentials, they're always infinitely wide, but logarithms, they're always infinitely tall. Okay. Take a few seconds, think about what we've discussed, last week and today. Fill in those 2 blanks for me. Remember, the end behavior is the left side and the right side. Okay, so what should the first one be? As x approaches infinity, the y values, f of x will go to infinity. And as x approaches -8, the closer it gets to the asymptote, the further down it goes. Okay. There's only one thing about this that didn't unfortunately work out in our favor. Okay. We don't see from the table exactly what that's got to be. Okay. And I think I might be a little off on this, but let's go ahead and plug this in the calculator. Log base 2. In fact, this is a good opportunity to go ahead and graph it and see how well we did with our sketch. So I'm going to hit control, but where do I find a log? 10 to the x, okay. So this was log base 2 of x plus 8. And then what was it, -4? Okay. So I'm going to go ahead and push enter. Okay. So I would say as far as our graph goes, it looks pretty good. Now, we can go ahead and run through the keystrokes here to go ahead and find that. I mean, we could also do it by hand, but I think that's going to be reserved more for when we do a later lesson. So let's hit menu. I want to analyze the graph. Remember, I'm looking for the x-intercept, so the 0. What does lower bound mean? Okay, so this is what I'm looking for right here, so I'm going to put it to the left, enter. Upper bound is the right. So it looks like it's crossing at 8. So I'm going to come on back over here. So we have 8, 0. Now, we are going to look at solving an equation for this later. You could also do this. Take the argument, whatever's in the parentheses for your logarithm. If you set it equal to 0 and go ahead and solve, that'll be your x-intercept. Okay. All right. Questions? Okay. Cool. Did anybody want me to go over that other method real quick, where you kind of pick and choose the points that you use instead of always starting with -2 and 2? Okay. So does anybody remember what we did the other day? Okay, what we're looking for in this case, we need to have powers on 2, right? So let's start with, maybe 0. Well, 2 to the 0 is 1. Okay. 2 to the first is 2. 2 squared is going to be 4, and etc., right? So we would have to evaluate the log itself before we subtracted the 4. So we're not really worried about that vertical shift. So let's think about it. I want to make sure that this argument equals 1. Okay. So what plus 8 would give me a 1? Oh, 7? -7. So see, I could start with -7. Because see, now if I go ahead and plug it in, log base 2 of -7 plus 8, well, that would be log base 2 of 1. Well, that would be 0. See, that would give me a point there. So basically, in this method, you're kind of just focusing on the log itself. Your argument would need to be the values after you place a power on your base. So let's try one more of these. Okay, like the next one would be 2. So I want to guarantee that this one right here is log base 2 of 2. So what plus 8 would give me 2? -6. Now don't decimals would be perfectly fine, but the whole idea for this method is, what if you didn't have a calculator and you just wanted to go ahead and get like perfect points? Is everybody okay with that? Okay. Okay. Cool. All right. How are we feeling about that? Feel pretty good? That's basically what your quiz is going to be tomorrow. Easy. Okay. Well, let's go ahead and put that to the side. And let's pull out this set of notes right here. So we're looking at logarithmic equations. Okay. Now, it works out really well. If your equation is already log equals log of the same base, you just mark out the logs and set one argument equal to the other. Now, occasionally, you might need to use one of those properties that we talked about. And here is a really super important rule. The argument, what's in the parentheses of your log, can never be what? Can never be negative and never be 0. Okay. So it looks like this past Thursday, we stopped at number 6. Okay, so we'll go ahead and skip around a little bit. I'll let you folks choose, 7 or 8. 7? Let's do 7. Okay, so 1/2 log base 6 of 25 equals log base 6 of 23 minus 4w. Now, there's nothing to condense, but there is one thing I want to take care of before I cross out the logs. If there's a coefficient, we want to go ahead and reapply it as a power. Now, we actually just saw this a few moments ago. What's anything to the 1/2 power? That's a square root. So this is going to be log base 6 of the square root of 25 is 5, equal to the log base 6 of 23 minus 4w. There you go. Once it's a log equals log, and they have to have the same base, that's what's key. I can just mark these logs out and say that this first argument, 5, equals the second argument, 23, minus 4w. There you go. It's as easy as falling off a log. Okay. So, and then we just go ahead and solve it. So what is a 5 minus 23? Okay. A negative what? Okay, 18 is equal to a negative 4W. Then we'll divide through by negative 4. Okay, so what am I getting? So this is going to be a fractional answer, and that's very possible. Positive 9/2. Or if you wanted to say 4.5, that's fine. Now, just for the sake of time, I'll go ahead and tell you that this works out. But it is super important. You always want to take a few seconds. Make sure that any answer you get, if you plugged it back in, doesn't make an argument 0 or negative. Remember, if it does, throw it out. What do we call that? Big word starts with the E. Extraneous. Extraneous. Okay. Did we want to do number 8? Okay. Well, I believe there's only a couple more in this section. So I'll let you decide. Do you want to do number 9 or number 10? Oh, get back. So number 9 or number 10. Or we could even do both. I know it's been 4 days. You're probably like, man, I want to do some math. Number 10. Okay, so log of 2 plus log of k squared equals log of k squared plus 16. Okay, so I don't see a base. What does that mean? It's base 10, so that's the common log. Okay, so first thing I got to do, I notice that there's no coefficient, so I don't have to worry about that. But I want to go ahead and try to make this a log equals log statement. Okay, these two logs are separated by addition. So will I multiply or divide those arguments? We're going to multiply, so I'm going to condense those. So this is just going to be the log of 2 times k squared is a 2k squared equals the log of k squared plus 16. Okay, once it's log equals log, same base, mark them out, you got your equation. Everybody remembering how easy this was? And fun? Of course. Okay. So let's go ahead and say k 2k squared equals k squared plus 16. Okay, so walk me through this. How would I do it? Okay, subtract k squared. So 2k squared minus k squared is just k squared, okay, is equal to 16. There we go. So k is equal to, now we're close. Is there anything we happen to be missing? Because we did take an even root when solving an equation. Plus or minus. Now that's still okay if I take the negative 4. Because if I go ahead and plug negative 4 in and I square it, what happens when you square a negative? That gives you a positive. So that negative doesn't give me a negative or 0 for any of those arguments. So both of those are okay. Okay. How are we doing? Okay. All right. Did we want to do number 9? No, we feel pretty good. Okay. Well, let's take a look. Here is a second type of equation. So it's not log equals log anymore. It's going to be a log equals some number. Okay, so step 1 says condense and isolate the log. Okay, number 2, write the equation in an exponential form, so we want to convert it. And then number 3, solve and check for extraneous solutions. Okay, so take a look at number 11. It says log base 2 of x minus 4 is equal to 6. So we want to isolate the log statement. Okay, so in this case here, I want to get that all by its lonesome. But what do you notice? It already is. There's nothing to take care of here. Now, in other problems, we might have something added or subtracted to it. We might be multiplying against it. That's what we're referring to. We want to get rid of any of those additional values. Okay. Once you've got the log statement by itself, okay, let's convert this to an exponential. Remember, there's always 3 parts. Okay, we've got the base. What do we call the parentheses? That's the argument. So the 6 has got to be the what? Remember, what is a log? It's a power. So I know that 6 is the power. Okay, so let's convert this. So this would be 2 to the 6th power is equal to x minus 4. See, because we only have one log, we can't cancel logs. We just have to convert it. Okay. Well, can anybody help me out? What is 2 to the 6th? 64. is equal to x minus 4. And then all I got to do is add 4, so my answer is 68. Okay. Well, let's see. If I were to plug 68 back in here, 68 minus 4, that's a 64. So yeah, log base 2 of 64 does equal 6. And more importantly, it did not make the argument 0 or negative. Yeah. Oh, not here because we didn't have to take a root. So see, that wasn't part of our original equation. Not like we did on the previous one. Okay. Now, even if, let's say, for argument's sake, we did get a negative 68 as an answer, what's negative 68? If I can write this way, negative 68 plus 4. Or is that a minus 4? That's a minus. Man. So let's just say, for argument's sake, what's negative 68 minus 4? That's a negative 72. Remember, no argument can be negative or 0. Okay. All right. Well, this is easy. So that means on number 12, it'll just be 3 to the negative 3 power equals 4x plus 8. No, why not? What am I missing? There you go. See, we haven't isolated this log yet. This is what I was talking about. We got to get rid of that minus 7. So let's add it. So this log base 3 of 4x plus 8, now it's going to equal what? Negative 3 plus 7? 4. There you go. Once the log is isolated, if you've only got the one log, now we convert it. Okay. What would that look like? Base 3 to the power of 4 equals 4x plus 8. That's exactly right. And then now we just go ahead and solve it. 3 to the 4th would be 81. So 81 equals 4x plus 8. Now I need an 81 minus 8. 73 equals 4x. And now what do I do? Now we divide by 4. So it looks like my answer is 73 fourths. And that's not a nice looking fraction, but yeah, it's perfectly fine to be an answer. In fact, I'll go ahead and tell you it does work if you were to plug it back in. Does anybody want me to plug it back in and show you? Yeah, it's back. Okay. How are we doing on these? Anybody having trouble? Anybody confused? Anybody stumped? Okay. You missed it. You know you did. Okay. All right, well, let's try number 13. Okay. So log of 2x plus log of x minus 5 equals 2. So this time we got 2 logs equal a number. What do you think we're going to do here? There we go. Let's just condense one side. 2 logs are separated by addition, so we're going to multiply. So I need to take 2x and distribute it across x minus 5. So that's going to give me log of 2x squared minus 10x equals 2. Now see, it's a log equals a number equation. Is everybody okay with that? Okay. So once you've got it down to the log isolated equals a number, what do? Okay. So what would that exponential form be? What's my base? Base 10 to what power? 2. And what would it equal? There you go. And this one resulted in a quadratic. It's okay. We've dealt with quadratics before. Now, 10 squared is 100. So let's rewrite this. We got 0 is equal to 2x squared minus 10x. And let's subtract that 100 over. Okay. So it looks pretty awful, right? But do you notice anything about A, B, and C? Yeah, they're all divisible by what? So I can go ahead and just divide that 2 out. And that will not affect the answer I'm getting. Now, if I were looking for the vertex, I definitely wouldn't want to do that. Okay, but let's see what we got here. 0 is equal to x squared minus 5x minus 50. So let's see if this one's a little nicer. What two numbers will multiply to give me negative 50, but they also have to add to give me a negative 5? Okay, so 0 equals, so it would be x minus 10 times x plus 5. Would everybody agree? Negative 10 times 5 is a negative 50. But negative 10 plus 5, there's your negative 5. Okay, that's great. How does that help me get my answers, though? We set them equal to 0, the zero product property. So if x minus 10 is equal to 0, we got x equals 10. If x plus 5 equals 0, x equals negative 5. Now, we got two answers, so let's check this. Let's check the 10. Okay. And right now, I'm not even worried about, checking the whole equation. I'm just looking at the arguments. Let's check the 10 first. Okay. So what is 2 times 10? 20, so that's perfect. 10 minus 5? 5. That did not make a single argument 0 or negative. Boop, we're good. Okay, let's try the negative 5. What's 2 times negative 5? Negative 10. What can the argument not be? Cannot be negative or 0. I don't even need to check the other one or keep going. I know negative 5 cannot be a solution. Okay. How are we doing? Cool. Okay. All right, so I'll tell you what. How about we go ahead and end? We'll do one more, and then we'll call it a day. 14, 15, or 16? What would you like? 16? Is that good? Let's do 16. Okay. All right. So we've got log of x minus 3 plus log of x equals 1. So it looks like we've got to do the same thing that we just did on this problem. Okay. Who can come up and walk me through this? Whoa, that's a lot of hands. I just need one. Oh, as soon as we do it, we're done. Heather, you go. Or I know that Kyla and Ava go a lot. Who's sitting there like, man, I never get to go up. We could do it as a group with a student. Yeah. Jane, you want to work number 16? All we're doing is one last problem and we are done. Oh my God. Pavi, do you want to go? We're here to help you. All right. Okay. Okay. Okay, so we got 2 logs equal a number, but we want 1 log equals a number. So what do we do? Okay. Okay, so we distribute x across that, and that equals 1. 10 to the first equals x squared minus 3x. Perfect. Everybody's okay with what she's got so far? Okay, so let's see here. 0 equals x squared minus 3x minus 10. Okay. So what 2 numbers will multiply to give me negative 10, but also add, give me negative 3? Okay, so x minus 5 times x plus 2. So if I go ahead and set those equal to 0, what are my 2 solutions? X equals 5 and x equals negative 2. Now, are there either of those that are going to cause a problem? The negative 2. For example, what's negative 2 minus 3? -5 cannot, even if you just plug it in here, it's already negative. Okay. So the only answer is 5. There you go. All right. Fantastic. Okay, so you got your assignment right there. We'll talk about that in a couple of days. Remember, tomorrow you got your quiz over graphing, and we'll go ahead and start the next round of equations. So, good job.